Hello and welcome to Section 5 of Riverbed's RCSA exam preparation series. I'm Bob Ashmore, I'm a Channel SE with Riverbed. Let's get right into talking about some of Riverbed's other products other than the Steelhead. First one we'll look at is the CMC, the Central Management Controller. The Central Management Controller allows you to manage multiple Steelhead appliances through a single GUI. Some of the features include the ability to do a touchless Steelhead configuration, which you're about to see. We can do global performance reporting, which gives you a bird's eye view of what's happening on all of your Steelhead appliances, as well as a central health monitoring. In a single view, you can see how all of your devices are doing and whether they're functioning correctly. Please refer to the CMC User's Guide for additional details on the features. What's important for us to know is what the purpose of the CMC is and how it fits into our Steelhead deployment. Touchless Steelhead configuration or deployment is very cool with the CMC. This allows us to deploy Steelhead appliances and configure them without actually opening the box. That sounds very difficult, doesn't it? Actually, it's not. What we do is we enter some key information into the CMC, and then we are able to configure that appliance, and when it is shipped and delivered, it will automatically pull down its configuration from the CMC. Let's look at how that works. First, the CMC is located in the data center, and then we place Steelhead appliances. They reach out and via DNS are able to find the CMC, whereby the CMC deploys its configuration for the specific devices to those devices automatically. What information needs to be gathered and what information needs to be provided in order to make this work? First thing we need is the appliance serial number. So we get the serial number of the appliance available on the outside of the box. Plug that into the CMC configuration. We need to enter the username and password. Remember that the default username and password for a Steelhead appliance is admin and password. Next, on the DNS server, this is not on the Steelhead and not on the CMC, we need to configure a name called Riverbed CMC. Make sure you know that it's a Riverbed CMC and not CMC Riverbed, not Riverbed underscore CMC. It's critical that it be exactly Riverbed CMC. We configure that in our DNS server, whether it's a Windows box or info blocks or whatever it is. And then we specify the IP address of the CMC for that name. So once the box gets plugged in, it uses DHCP to get itself an IP address and also gets a DNS server, and then the Steelhead asks DNS for the IP address of Riverbed CMC, which it then uses to connect to the CMC, and once it connects to the CMC gives it its configuration. Next, let's talk about Steelhead Mobile. Steelhead Mobile is virtually the same technology as is available on the Steelhead appliance, but in a software version that can run on a laptop or a desktop appliance device. So an actual end user device can be running the Steelhead optimization technology using Steelhead Mobile software. Now there are some components involved. One of those components is the Steelhead Mobile Controller. The Steelhead Mobile Controller does three things. It provides licenses, it does reporting, and it does deployment of profiles which are used to define how optimization will be completed. Notice that it does not do optimization itself. It's not an optimization endpoint. Steelhead Mobile software optimizes between a Steelhead Mobile software device, like a laptop, and any Steelhead appliance in the network. A laptop can be optimizing with two different Steelhead appliances at the same time. For example, if I have a server in New York and a server in San Francisco that I need to access, I can have separate optimization going between the server and the Steelhead appliance in San Francisco, as well as between the server and Steelhead appliance in New York. All right, let's look at how that works. First thing that happens is the Steelhead mobile controller will distribute the Steelhead mobile software to the laptops and other devices that need to run it. It's not a push, it's a pull, so we provide a web server on the Steelhead mobile controller, which the clients can hit, and then updates to the Steelhead mobile software as well as configuration changes are automatically deployed using the Steelhead mobile controller. Next, once the software is installed on the Steelhead mobile devices, we reach out and grab a license. So each device goes to the Steelhead mobile controller and checks out a license. It's important to know that Steelhead Mobile is licensed using concurrent license model. So I can deploy the Steelhead Mobile software 300, 400, 500 clients, but as long as only 100 of them are connecting at the same time, I'm fine. Once I exceed the number of licenses that are allowed to connect to the Steelhead Mobile controller, then those devices will not be able to optimize. And then it's a good opportunity to contact your Riverbed partner sales rep and add additional licenses to your Steelhead Mobile controller. Once we've checked out a license, then we optimize. That optimization occurs again between the Steelhead Mobile client and any Steelhead appliance on the network, specifically the one that's closest to the server. Let's look at some of the SMC connection considerations. So there's a host-based firewall on most Windows laptops that must allow TCP port 7801 go through. So, and by default, the Windows firewall is configured to block port 7801. So we need to make sure that we open that up on local loopback. And information in detail on about how to do this is available inside the Steelhead Mobile User's Guide. Remember that firewalls, IPSs, or proxies may strip our discovery probe, so that may force you to use a fixed target rule. We often use fixed target rules with Steelhead Mobile deployments. RIOS 4.0 is required, and when we're deploying the mobile client as part of a binary desktop image, if we have a gold disk that we're creating, for example, we need to make sure that we remove the XML and, files that are listed here, which will automatically be recreated when the client starts. So, as was mentioned, the Steelhead Mobile environment consists of software that runs on the Steelhead Mobile device, like a laptop, the Steelhead Mobile controller itself, and a virtual version, SMC VE, the virtual edition, is available to run on RSP. However, note that the SMC VE is limited to 100 concurrent users. If we want more than 100 concurrent users, we need Steelhead Mobile Controller Appliance, which will support up to 4,000 concurrent users. Steelhead Mobile Controller End User Management allows you to see all of the Steelhead Mobile users, what kind of optimization they're getting, how long they've been connected, which applications they're using, and how much compression and reduction they're getting. Some of the things we should make sure we understand are the differences between endpoints and endpoint policies. An endpoint is a device. A policy is a configuration template for a group of clients that have the same type of configuration requirements. Now we have packages, which are the MSI packages, which are deployed to install the Steelhead Mobile software on the client. Then we have an acceleration policy that specifies, similar to in-path rules, which traffic will be optimized in which way. There are deployment IDs and assignments that are used to identify individual clients and their endpoint and acceleration policies. What we should make sure we know here is the difference between what information is available in an endpoint policy and what information is available in an acceleration policy. An endpoint policy contains information, for example, about the hardware. So how big of a data store should be configured on the laptop would be part of the endpoint policy, whereas an in-path fixed target rule would be part of the acceleration policy. All right, next let's talk about the interceptor. So the interceptor is a physical device that handles interception of traffic and then load balances that traffic across multiple steelhead appliances. The interceptor handles the interception, offloading that piece of work from the steelhead appliances itself, and then, as I mentioned, load balancing across the appliances. The interceptor can handle up to 1 million optimized connections and up to 12 gigabits per second of optimized traffic. The steelhead appliances are connected using WAN 00, as we mentioned earlier, with other forms of logical in-path configurations, like WCCP or PBR. The interceptor uses connection distribution that is RIOS aware, meaning that we keep track of where the traffic is coming from and send that traffic to the same steelhead appliance. That way, if I've got users at one branch office that are all engineers and another branch office is full of marketing people, then the engineers use the same steelhead at the data center and the marketing people use their own device at the data center. This way the data stores are warm for each type of user. The steelhead automatically configured these, and we refer to this as pure affinity. We also fully support asymmetric networks. So you can configure connection forwarding between the interceptors, and the interceptors will automatically make sure that traffic that is destined for the WAN will use the same interceptor as it used previously. As mentioned, pure affinity redirects remote steelheads to warm data stores. Connection forwarding supports parallel interface scaling, as we just saw. We have sequential rules processing. These are similar to the rules that you see in in-path rules. We step through the list of rules, and the first one that matches is the rule that is executed. And lastly, we do intelligent forwarding. So there's no need to configure static routes. There's no need to figure out where the devices are trying to send their packets. The interceptor does that automatically on its own. Next, let's talk about Cascade. Cascade is the line of products that were acquired through an acquisition by Mazoo. Cascade provides value in the way of WAN management, provides a plan for WAN optimization. You can assess the impact of a steelhead deployment to see how much optimization you're getting, and you're able to analyze WAN and LAN traffic from the network all the way up through layer 7. There's also the ability to do data center management, and these products are used frequently in data center consolidation projects, wherein we're trying to determine which servers are being used by whom and which servers can be decommissioned as they're not being used by anybody. Obviously, we're able to monitor application delivery on the network and determine which applications are performing as we would like them to do. Deploying Cascade involves various devices, and we need to know what these different devices are. So we have the profiler, the gateway, and the sensor. One way to remember this is GPS. The sensor is a device that does layer 7 analysis and deep packet inspection, and also collects information about response time. This is done either using a span port, which is configured using the monitor command on a Cisco device, or using a physical tap to redirect traffic and to analyze that traffic and collect that information in the sensor itself. Then we collect information from NetFlow sources. The NetFlow sources send information to the gateway. NetFlow goes to the gateway, then the gateway and the sensor information gets sent to the profiler. The profiler is the box that you're going to log into and do all of your analysis on. Analytics are running constantly on the profiler and allow you to manage the Cascade environment. Once the boxes have been deployed, you will not be logging into either the gateway or the sensor. All of your work is done on the profiler. Also note that there is a virtual edition of the sensor, which provides response time analysis, but does not provide the layer 7 deep packet inspection, as that requires a special piece of silicon, which is only available on the sensor appliance. So the sensor VE will send information similar to a standard sensor appliance. That all gets sent back to the profiler. In short, we need to remember that we have gateways and sensors that send data to the profiler, GPS. Some things that we should keep in mind when we're doing sizing. The gateways and profilers are sized based on flows per minute. We estimate about 20 flows per minute for each node on the network. So each server and each client and each printer are considered a node, and then we say 20 flows per minute for each of those nodes. Sensors are sized by the number of physical ports on the sensor and whether they're copper or fiber. Okay? Next, Cascade does not collect any hardware information about the servers or the clients. You guys have other tools that can do that. Cascade is not the type of tool that will tell you what version of Outlook is running on a client's laptop or how much RAM is configured on a particular server. You will not get that kind of information from Cascade. Also note that there is Cascade Sales Accreditation Training. We highly recommend that you try that out. It's on the Partner Center and allows you to get additional good information about Cascade. All right, let's look at some sample questions. The first is, Cascade is beneficial to which areas of the enterprise? A, WAN optimization, WAN shaping, QoS policy enforcement. B, WAN management, application performance, and data center management. C, reporting, asset inventory, and ticketing. And D, SNMP, trap monitoring, and log consolidation and correlation. Those all sound like cool things. However, B is the type of WAN management information that you can get from a Cascade environment. Next, what are the 3 components or appliances that a complete Riverbed Cascade deployment would consist of? Remember GPS. So we've got a gateway, profiler, and a sensor. That's C. Next, you're deploying Steelhead Mobile with the server-side Steelhead deployed server-side out of path. What do you need to configure in the mobile controller so that clients optimize traffic to that Steelhead appliance? Again, the Steelhead appliance in the data center is out of path, server-side out of path. The only way to get connections to that device is to use a fixed target rule. Next, what is the well-known DNS name that needs to be configured for having Steelheads use auto-registration with the CMC? Let's make sure we get this right. It's Riverbed CMC. Next, how many concurrent TCP connections does the Interceptor 9350 support? We covered it a couple slides back. It's 1 million connections. Next, what are the 2 benefits in using a CMC appliance? So A is centralized monitoring of Steelhead appliances. That sounds good. And B is centralized reporting of Interceptor appliances. I don't remember talking about that. Centralized reporting of SMC appliances. Centralized configuration of Steelheads, and centralized configuration of Cascade profilers. So today, and for the purposes of this exam, the CMC only supports configuration and monitoring of Steelhead appliances. So that would be A and D. Next, how many Steelhead appliances can an Interceptor appliance support in a single cluster or group? Interceptors support up to 25 appliances. Okay. Once a Steelhead mobile client connects to the mobile controller, what does it receive from the SMC? What is the purpose of the Steelhead mobile client talking to the SMC? Well, it's not the Steelhead Domain Catalog Descriptor database. It's the license B. Next, in a cascade deployment with a sensor and profiler, what information does the APP, the Application Performance Policy, report show? Everything except for jumbo frames and CPU and memory utilization of the server. And that's the end of section 5.